All right. So today we're going to be learning about Git and GitHub. We're going to be talking about the difference between Git and GitHub. And really, Git should have the lowercase g and GitHub the uppercase g. That's normally how you'll see these terms written. We'll learn how to create a Git repo without using GitHub. We'll learn about the Git add command, the Git commit command, the Git status command, making branches, switching between branches, which is called checkout in Git speak, and merging, which is combining branches in Git speak. Um, some of this will be review for some of you. Some of this will be new. You all will be using Git and GitHub every single day of the course because each assignment is its own GitHub repo. And we have a sort of workflow that we want you all to do to get practice using the command line and practice using Git and GitHub. Any questions about the plan for today's lesson before we dive in? Okay, cool. And hopefully we should be able to get through this in about an hour, take a break, get some work time in, and then we'll move on to diving more into GitHub. Um, I know a number of you did FOP. Let me just get a quick show of hands to see like how many folks have used, Git a little bit before. Almost everyone. And if not, that's okay because that's really what today is for. Um, I don't know about you guys, but I find Git on the command line a little arcane and confusing. Does anyone else feel that way as well? I see a couple nods. I see some maybes. I will say the more you use Git, the more I think the commands get frustrating. It's not that it doesn't make sense, but it's sort of notorious in the programmer world as having sort of like a more arcane and confusing set of command line commands and names. And you use the same command to do different things, but with flag. And that's in part why GitHub kind of created this GitHub client to clone repos and stuff. And Git itself, in fact, has some newer commands in the newer versions to try and kind of make it easier. So, point being, if you find Git on the command line frustrating, you're not alone, and you are correct. Um, the other thing I would ask is, so how many people here like feel really comfortable like explaining what a commit is in Git? And honestly, I probably would have to put my hand down as well, or also do the wavy thing, because some of the concepts are really simple, but others get more complicated. And there's actually like a couple cool kind of computer science concepts hiding under the hood with Git. And there's a lot of things that you don't really encounter outside of programming. So there aren't a lot of sort of metaphors to use that we can draw from. And I think a good starting point, just to talk about what the heck Git is just to talk a little bit about version control. So, version control is a fancy word for being able to keep track of different versions of a document. And I'll bump this up a bit, but it's not so important to read what's in here. And in Google Docs, if you go to File and you scroll down here to version history and you click on See version history, I can see different versions of my document. And if I want to, I could even name this. And this is useful because, you know, now I'm going to change it. Um, and, if I go over here and we look at our version history again, well, I can go back and forth. I can see the changes. I can give this a name, draft two. And for something, like this isn't that big a deal. But if, we're lawyers drafting like a 500-page contract, this kind of stuff is actually a really big deal. and maybe the head lawyer says, you know what, I don't like this version, I like draft one better, and we want to go back to draft one, right? Or even worse, maybe we had like changed something and lost something important. The version history lets us go back in time to get that. So version control software or version control tools accomplishes this same goal, but it's not just for a file, it's for a whole code base, right? Because as you guys will see, really tomorrow and Thursday, but especially next week, like to design good maintainable programs, you start to need more and more files, and it just gets bigger and bigger and bigger. So it's not enough for me to just track the versions of a single file. I need to be able to track the versions of like all the files in a directory, and in fact, like multiple directories across a whole project. There are a bunch of different version control systems out there. Before Git, there was something called, I think, Mercurial. There's something called SVN. Um, Google, I think, built its own. Git was actually created by the same guy who created Linus Torvalds, excuse me. And kind of the thing about Git that makes it special is it's distributed. And what that means is I can have, let's say we have a couple different people working together on a project. And let's say we've got like Alice and we've got Bob and we've got Carol. And they're all working together to write code. And this is kind of how Git was created. In fact, it was created to help deal with managing Linux as an open source project. Well, I might have a Git repo, and I think I'll use a diamond to represent this. And Alice has a Git repo on her machine, and Bob has a Git repo on his machine, and Carol has a Git repo on her machine. And it's all the same project. But maybe Carol has written some code that she wants to send to Alice. Well, I can use Git to get Carol's code. Maybe Bob has some code that he wrote that he wants to send to Carol. And the arrows here are going to be a little confusing. So just ignore the directions of the arrows because Alice is pulling from Carol, but Bob might push his code to Carol's Git repo. And similarly, you know, Alice and Bob can be sharing code as well. And so really these arrows run in a bunch of different directions. And I'll get into the mechanics of this in just a minute. I realize this might be a bit abstract right now. And in fact, we don't really use Git this way most of the time. But what this does illustrate is the idea of sort of a peer-to-peer network, but for like version control, right? And some projects might use Git that way, but frankly, it gets kind of complicated kind of fast. And so like 90% of the time, the way we actually see people using Git that I think we're all way more used to is here in the cloud. Let's just call this GitHub. There's a Git repo, and it's our project. And I am going to hop back over here, and I'm just going to borrow Carol and Bob just for simplicity. And let's bring Carol and Bob over here. And they're not doing all this stuff. All this stuff goes away. They're both centralizing. And this is probably what most of you are used to. Just can I get a quick show of hands if you've ever cloned a Git repo before? And how about if you've ever done Git push? And if you've ever done Git pull? So a number of folks, and I know it's mostly the folks who did foundations of programming. And again, if this is all new to you, that's okay. That's what today is for. So for those of you who have done it, you're familiar with this. For those of you whom this is new, don't worry about the details. We're going to get into the details in just a minute. Just kind of step back and focus on the big picture here, which is I can have a Git repo on my laptop. I can push code from it up to a Git repo on a server in the cloud on GitHub. And then a teammate can pull that same code from the Git repo in the cloud onto their Git repo on their machine. So this is where we're going to end up. Where we're going to start is just with the Git repo on my computer. And we're not even going to worry about the cloud or sharing, and we're going to see sort of the fundamentals of Git. And so for the moment, I'm just going to make the terminal bigger because I'm going to be doing a lot of terminaling for the next couple minutes. And I just want to see if folks have any questions before I dive in and start writing some code.
I guess let's say while we've had exposure, it's not like we work with it like how we worked with on a regular basis.
Yeah,
So the review is still definitely very helpful, even
for
though we've
sure.
had some exposure.
Awesome. And that's what today is for. And actually, let me just give you all sort of a preview. So we put the entire curriculum in a Git repo on GitHub. Um, and we do it for the same reason that people put code in there because it lets us track versions. And if I'm just going to do a little annotating, over here we have GitHub has the idea of an organization or an org. And within that, you can have different repos or repositories, right? Repo is short for repository. And in fact, if I click on this, I've added a little README here. I've added links to some important repos. I've pinned some repos. And if I click here on repositories, I can see all the different repositories in this org. Um, Again, for all of you, our curriculum repo is really the only important one. For most of you with your own GitHub accounts, you're used to seeing something like this where it's exactly the same thing. You can have and customize a README, and you should, and we'll talk about it later. And I have not been doing side projects in way too long, so mine are ancient and old and sad. But I have a bunch of tiny little things. It's honestly mostly copy and code platoon assignments. Trust me, some people are very good about doing side projects. I am not one of them. But again, what we see here is instead of the GitHub org, it's the GitHub user, which is really kind of the same thing. And then the repo name. So just to point out sort of the naming convention on GitHub, and you see it reflected here in the URL as well. And just to give a bit of a preview of what a repo does and why we care, and I'll talk more about what a commit is in just a minute, but by clicking on commits, I can see a history of all the changes, right? The same way if I go here in Google Docs to version history, see version history, and I can see all these changes. Well, we have to manually create these commits, but you can see all these changes. And so here's one I did last week. Each commit has a unique ID, and you can see that I changed one file, right? And I added a link to a slide deck. And so we can go way back in time and we can see a bunch of changes. We'll talk more about, sort of merging and stuff like that later. This one, we can see, in fact, 41 files were changed, but in fact, it was just me renaming them. So a commit is not just the change in one file, it's potentially the change in a bunch of files. And we'll get there later. But I just kind of want to give a bit of a preview of sort of where we're going to end up, because this is exactly what it would be like for a code base. And I just want to see if folks have any questions before I now finally do start writing some code and fiddling around with Git. Okay, awesome. So uh, Git and GitHub are two different things. GitHub is like a cloud service provider for Git, right? Plus, it has all of this. It's essentially like sort of social media for programmers, like having user profiles, and you can have messages, and you can create issues, and you can follow repos, and it has a really nice user interface. So it adds all this other stuff. But at the end of the day, it's a bunch of servers in the cloud running a bunch of Git repos, and Git is the main version control program. So I just want to emphasize that point. And let me just scroll down a bit to kind of my guide code here. Um, Making a Git repo is really easy. I'm going to make a directory first. I'm going to navigate inside it. And there's nothing in here at the moment. And there's no dot files. And to create a Git repository, a repo, all I need to do is run this command, git init. And now if I type ls space dash a, we see this dot git. And if I do git log, good. Okay. I got a little worried because I'm actually creating this inside another repo, which is actually not a good idea, but is fine for now. So that git init command, it created this .git directory. And that's where everything in the Git repo lives. And let me actually demo this outside the, I want to get outside the, I'm in the demos and notes repo now because I want to show you guys what it looks like outside a repo because something else happens. So let me make a directory, my first repo, and let me go ahead and navigate inside here. Look at the command prompt. Normal command prompt, right? Git init. Now, this is, I think, ZSH doing a little work for us. Our shell recognizes we're in a Git repo and that we've checked out a branch named main. How does that happen? It happens because of this .git directory. If I delete that directory, the Git repo is destroyed. And it's as simple as that. And so a Git repo is just a directory that has this .git directory in it. And that's where all this stuff is going to get saved as we make commits and stuff like that.
So the Git init makes it into a repo?
Yeah, exactly. And init is short for initialize. And it creates a repo in that directory. You guys won't have to use Git init that much because when you guys use git clone to clone a repo from GitHub, it will do the init step for you. But I want to show you all the manual steps just to understand this a bit better. There's a lot of interesting stuff inside the .git directory, but we will go into that in a later date. The one thing I want to point out now, because we will mess with it a bit later, is inside that directory, there's a file named config. And we'll be adding some things to that as time goes on today. But that's where everything lives. And that's this .git directory is what makes a Git repo a repo. So now that I've got a repo, I can type git status. And this is my favorite command in the world. I type git status all the time. Git is confusing. I triple check everything before I do it in Git, and I literally type git status after every single command. It tells me what branch I'm on. We'll talk more about branches later. No commits, right? I haven't made any changes to any files or directories. I will talk a bit more about what this command means as well. You can do git dash dash help, I believe, and it will give you a list of a bunch of commands, and that can be useful. I think if you do man pages for Git, you will get a bunch of commands. But to be honest, looking stuff up online is probably going to be by far the easiest way to do it. And we have some good references, and I would use our curriculum as a resource as well. So let me go ahead and make some files. And I'm going to go ahead and make 3 different files. And I haven't put anything in them, but now they exist. And let me go ahead and open up one of them and put some stuff in there. And let me give myself a little room. Let's close out the README out. We'll leave the README there. Let me open up the text file. Right, so I've got these 2 tabs, but this is the file that we care about. By the way, note that you've got these nice breadcrumbs here. You can actually use this to navigate around, which is kind of nifty. And let's just put a hello world message in this text file. And you know what? I want to edit the Python file too. And let's print hello world. And you know what? I want to edit the JavaScript file too. And we'll do console.log hello world. Now, let me go ahead and type git status. 3 untracked files. And this really interesting suggestion here, use git add to include what will be committed. So everything in Git exists in one of 3 states. And let me draw a couple boxes here. And bear with me just a sec as I make my boxes. Everything in a Git repo is in one of 3 states: unstaged, staged, or committed. And unstaged, you'll also see call untracked, so that's a little different. Staged, you'll also see added, and committed is a bit more self-explanatory when we get there. And to stage something, we run git add and the file that we want to stage. Once I've added a bunch of changes, I can commit all those changes in a single commit with the git commit command. And we're going to do, we'll just do git commit, and we'll talk about -n later. So there's a lot of different ways to add and commit stuff, and I'll go through all the examples. But let's start with the simplest one, which is adding a single file. And let's start with our JavaScript file. So let's do git add. example.js. And now if I type git status, I see that this change is ready to be committed. This is what's called staged. So if I have my kind of 3 change sets in here, example py, example js, example txt, the JavaScript file and the changes in it have just been staged. Now let's go ahead and make this commit. For all of you in Install Fest yesterday, when we ran that one git command to like change config for core editor to VS Code, that should do this so that when you run git commit, it opens up this sort of temporary file in VS Code. Otherwise, it will use a less intuitive command line based text editor such as Vim or Nano. And if any of you, when you run git commit, don't see this, let me know and I'll help you get it set up. And here we can type a message. And you'll see like commit messages often are quite long. All of these lines with the pound sign are commented out and won't be committed unless I uncomment them. So, Git sort of gives us some helpers. But I'm going to just say like create example.js, and maybe we'll add a bit more information. And the feature we add is print hello world. I have to save this and I have to quit it. When I'm done, now if I type git status, that file is no longer staged. It's been committed. And these 2 here are still untracked. And I can use this command git log, which is your best friend, to see a history of all of the commits I've made. So I'll talk about in a minute why this matters, like what the value of committing is. I just want to check in and see if folks have any questions before we keep on rolling. Okay, cool. So let me show you how to do the same thing, but a bit more easily. We staged and committed one change. Often you might just want to add or stage and commit all your changes. By the way, when you're writing code, the rule is commit early, commit often. Most of my commits are like 2 lines of code. There's really no downside to making lots of small commits. Because what we'll learn how to do later is if you make a mistake or you get stuck and you need to go back to a previous version of your code, you can, but it's based on our commits, right? Those are the different versions of our code base now. So I can do git add, and I don't have to give a file name. I could add a pattern. We haven't really talked about wildcards yet, but this would add all Python files. This would add all JavaScript files. This adds all files. So if I do git add dot, and this is what you're going to do most of the time, now both of these things are staged. And the way I think about staged over here is imagine that we're baking like cookies, right? And over here, all this unstaged stuff is like the raw cookie dough, or maybe I've formed stuff into cookies, but now we put it on the baking tin. Because when I put the baking tin with the cookies in the oven, the cookies become cooked and formed. And so now I'm going to do git commits, but I'm going to do -m. And this little flag is your best friend right now because -m stands for message. So remember how that kind of text editor window popped up before? Well, sometimes I need to write a nice long commit message. Most of the time, it might be really short. And now I can just write a nice short commit message. Um, and now both of these have been committed as well. And I actually have two commits. So let me draw some ovals here. And actually, the way it kind of works is this was the first one, and this was the second one. We'll talk about this more later. But if I type git log, we now see those two commits, right? And note, by the way, this unique string of numbers and letters called a hash that identifies each commit. That later on, not today, but we'll learn how you can use this to grab an individual commit. And it automatically adds the date, it automatically adds the person that created it. And so now we have two commits. You can do a lot of interesting stuff with commits. You can check out an individual commit. And now what I've actually done is I've actually gotten rid of those other files. And I'm in a previous point in my code base. You're not going to need to do that often, so don't worry about it too much because it'd be a bit confusing. But we're going to see something similar happen with branches in just a minute, and that's kind of where the magic of Git starts to come into play. Because just like once you bake some cookies in the oven, like that cookie dough is done. You can't reform it into something else. Once you commit code, Git saves all of the changes in that commit. And in fact, there's this great command called diff, which stands for difference. And I can look at the changes between my current commit and a previous commit. You can do this in VS Code as well. If I expand VS Code a bit here and I go to source control, I don't know why my sidebar has gotten so weird. It's honestly, I find it a little confusing. But you can look at the changes in individual commits. I actually don't recommend using this. It's really valuable to get comfortable with Git on the command line. So let me go ahead and make one more change, and we'll talk a little bit more about the fundamentals of Git, and then I'll talk about branching. And I just want to check in and see how people are doing. Like, are you tracking? Does this make sense? Are people wondering like why do commits matter? Why do I need this? Because we haven't really gotten there yet, so that'd be understandable. Okay, awesome. So let's go ahead and let's modify one of these existing files. Let's take example.txt and let's add goodbye world to it. And now if I type git status, I see that this file's been modified, right? Because Git tracks changes to files. It's not just about creating files, it's about changing them. And I'm going to do git add example.txt. I'm going to do git commit -m add goodbye to example.txt. I would use double quotes for commit messages, by the way. I thought the period would actually break it, but it didn't. But I think a slash and maybe other certain special characters could cause problems. So if you're doing -m, which I do recommend for simplicity, at least starting out, if you use double quotes, you'll make your life a little easier. And now if I do git log, we've got add goodbye, right? So what just happened here? We had unstaged and I have to add two things here because just to help us see better, right? And then this was added, and then it was committed. And now we have 3 commits in our commit history over here. And note, by the way, when I run this git log command, the most recent commit is first. And there's this really interesting little message here, head arrow main. Let me take a minute and talk about what that is. And let's make this bigger. And let's bring these over here. Let's delve a bit more into sort of the anatomy of Git and Git commits. So we've got 3 commits. I'm going to make these ovals just a bit bigger. Or we'll leave them as is because I don't want to mess with it too much. These commits are on the main branch. And the way that commits work in Git is when you make a new commit, it has a reference back to the previous one. And it's sort of like a chain going backwards. So our very first commit doesn't have a reference back to anything because there was nothing else. And I think I screwed up our ordering here. Indeed, I did, because this has a example PY as well. So let me add that in just for so the diagram remains correct. Right. And if I'm gonna, do a little bit of numbering, that was our very first commit. This was our second commit, and this was our third commit. And each commit points back to the previous one. And what Git also does is it keeps track of the most recent commit. And think of it as a variable. The same way I could say x equals 5. Well, each of these commits has a unique ID, right? That hash that I talked about. And I'm going to add I'm just going to make up the hash numbers. And I'm just going to put them in red. And again, the hashes are actually generated. They're guaranteed to be unique using something called a hashing function that we'll talk about later. But so this is a unique ID for each commit. So the same way, if I'm creating a variable in Python or JavaScript, I can say x equals 5. I can say head equals DEF456. And so, in fact, what was happening every time we made a commit, that first commit, Git set this special variable called head to XYZ123 to this commit hash. Then when we made this second one, it set it to the commit hash of our second commit. And then when we made the third one, it set it to the commit hash of our third commit. And this is how Git keeps track of stuff. Because if each commit kind of points to its parent, the one before it, and we have the most recent one, I can work my way back down the chain. And when Git wants to construct the state of a code base, it takes this change, or it starts here and it kind of adds it on top of that, and it kind of adds it on top of that, and that's how we get the code base. And so head is an alias pointing to the most recent commit on the branch we have checked out. And we haven't talked about switching between branches, using different branches, but we will in a minute. And I just want to point out something really interesting. We don't need to go too deep into this, but if we look in this .git directory, there's this file here named head in all caps. And if I print that out, it says ref, which is short for reference, and it's refs/heads/main. And if I look here, there's a refs directory. And if I look inside that, there's a heads directory. And if I look inside that, and you guys aren't going to have to mess with this, Git handles all this stuff automatically, but I just kind of want to poke under the hood. There's this file. And that's a commit hash. And if I type git log and I look at this commit hash right here, it's the exact same thing. So again, don't worry about the .git directory. You're not going to have to modify it directly ever. And in fact, you shouldn't. And in fact, you should never delete a .git directory, by the way. If you are ever having an issue with Git and you think the solution is to delete the .git directory, come find a TA or an instructor, because that almost always means there is a different solution to the problem. And often that's how students lose work without meaning to. So just file that away. Don't delete a .git directory on your own. Make sure you check in with the TA, and TAs feel more than free to check in with me and Francisco, because that's usually how people run into trouble. So we've gone kind of into the guts of Git a bit here, but the main thing I wanted to point out is that none of this is happening by magic. Git actually has a bunch of text files in that .git directory it uses to keep track of stuff. And these commits link together, right? From most recent to previous. And I just want to check in and see what questions folks have, because this is probably a good stopping point to take a short break. And then when we can come back, we can talk about branches, which is where this starts to become even more interesting.
So,
yeah.
Do you mind recapping, I guess, how to load a previous commit, like when you have the address, or like when you do git log and it pulls up,
Yeah.
like say like quick commits and the addresses, how would you
Yeah.
revert back again? I know you went over that. I just need a recap.
No worries. And honestly, I only showed it very briefly because without branching, it's something you kind of want to do with caution. Yeah, and actually, let me make a quick comment to that effect. As you guys start out, on a practical level, the best thing to do is make lots of little commits and always push your code to GitHub. And if you need to go back, I would honestly just look in GitHub and like copy and paste the code, because you can kind of get into trouble going back in time, so to speak, and you kind of need branching. But yeah, let me show you guys. So git log is your best friend. It shows you all of the different commits. And by the way, now that we know about this head pointer or variable, if I want to look at the difference between the most recent commit and the one before it, I can to git diff head -1. And this will show me the difference between my current commit and the one before, right? And that was where we added goodbye world. If I want to look back 2 commits, I can do git diff head -2. And similarly, if I want to check out a commit, like if I wanted to go back to the very first commit, there's 2 ways to do it. I can type git log, find the commit I want, copy it, and the command is checkout, which is confusing because we'll also use this for branches. And you get this big warning here. We're now in detached head state. You can make experimental changes and discard commits without impacting any changes. If we want to save the changes, we actually need to create a new branch. If you want, this is why I say this with caution, because until we kind of see branching, this isn't so useful, because if I type git status, I'm not on any branch right now. But so it becomes more useful with branching if like you need to go back in time, because what we really want to do is stay on the main branch. So I can go in here and I can change stuff, and there's not a lot in here. So I can go ahead, I can add that, and if I type get status, well, that's there. The problem starts to become if I add this. What branch am I on? I'm still not on a branch. I'm sort of on this like detached state. At some point, I need to come back to the main branch, if for no other reason, so I can push my code to GitHub. And to do that, I need to run git checkout main, the name of my branch. This is where Git gets confusing because you use checkout to switch branches, and you can use checkout to check out a commit. They do have this switch command that's newer, but you won't see it everywhere. And now I get this warning, and it's telling me if I want to save this, I need to make a new branch, but it's already switched. So without branching, going back to a previous commit isn't very useful, if you know what I mean. But we'll see how to do that later. The other way to go back in time is git checkout head -2. And it does the same thing where we're at some previous commit state. But honestly, folks, I would not worry about that right now. But yeah, that's a great question, and it is good to see that, and we will kind of be messing around with it more later. What other questions do folks have before we take a break?
So to clarify, uh,
Go ahead, Kenny.
so to clarify, when you stage, unstage, or commit, it doesn't technically change the file. It just changes the information Git keeps track of.
Great question. Two things happen. And actually, let me just demo this. Yeah, that's a really good question. First, I change the file. If I type git status, and let me put this in here and kind of navigate back over to our other diagram. So I have changed the file. For example, py, goodbye message. I'll just put Git. The way to think about it is Git sort of like creates a database inside that .git directory. It's not quite a database like Postgres, but it's similar enough. And so I've changed my file, but right now, anything unstaged or untracked, like Git doesn't save it or give me any protection. Until code is committed, it's not in Git. Like if I delete this and I type git status, then it's just gone. Git add adds a little bit of protection. Git keeps track of stuff that I've added or staged. And if I try to do certain things like checking out a different branch or something that might delete this, Git will actually stop me. But it's not sort of complete protection, and it's not sort of saved long term. When I type git commit, and now I've added another commit here, right? So if we go actually over here, we can. Sorry, my TL draw skills are rusty. Where we actually now have a fourth commit. And it has another, I'm not going to write the commit message and stuff, but like the head now points to, and this commit points back. So as to your point, like, what is Git keeping track of? That's a really good question, because I've got files and I've got commits. And you're right, they're not the same thing. And we're actually going to see this after the break. But let me go ahead and make a new branch. I'm going to do this with, I think it's like checkout.b, my new branch. So this is a little bit of a preview, and then we'll take a break. But Penny, I'm glad you asked, because I think this is good to see, and this is great to see before the break. So if I type git branch, I've got these two branches. And I'll talk about what happened, but because we kind of created this branch off of main, it has all the stuff that we had. But watch this. I'm going to delete example py. I'm going to delete example txt. I'm going to delete example JS. If I type git status on my new branch, well, Git says, oh, these files are deleted, but I haven't added any of that. I haven't committed any of that. Let's go ahead, do git add, git commit. And now those files are gone, right? I indeed have deleted those files on my file system. Watch what happens when I switch branches and check out the main branch. Those files are back. So Git will actually like manipulate our files, but that's the power of a commit. It actually saves stuff. So on one branch, I can like delete stuff and mess around with stuff, and then I can switch back to the other branch and still have all my code. So I think the way to think about it is like Git commits, Kenny, you're totally right. Like a commit is not actually a change to a file. It's like you said, it is tracking all of those changes, but it's saving them in Git for us. I realize I may have overcomplicated that a bit, so I just want to check in to see if that is helpful or maybe had a little too many twists along the way.
Yeah, I ain't gonna lie, it might have been a little bit too many twists along that way, but I was tracking
Yeah.
before that.
And we're gonna dig into this more after the break too. This is a bit of a preview because we'll talk about branching after the break. I think the main thing to take away from this, because I'll talk about branches and stuff in a minute, but like when you commit stuff to Git, it's saved. And even if you delete the file, all those commits are still there and you can go back and get them. And that's the key thing. Like once I've committed something, it's in my Git repo till the end of time. And so even if I delete files and stuff, I can always go find those commits. Yeah, and everything else is kind of filler, and we'll talk about it after the break. All right, let's take 10, folks, and then when we come back, I'll give a proper introduction to branching. And I think that kind of will take us to the end of part one, though there is a little bit more because there's checkout and merging. So I apologize. Our work time may get cut into a little bit today, but we've covered a lot of ground. We've talked about creating a repo. We've done a deep dive into commits. We've used Git status, and we got a little bit of a preview of branching. So after the break, we'll do a proper intro to branching, and we'll then also see how to combine branches. So have a good break, everyone, and I will see you all in 10 minutes. Thank you. All right, so we've learned how to create a Git repo with Git init. We've seen how if I make a change to a file, I can do git add. And if I do git add dot, what does that do, by the way?
It adds everything.
Yeah, it adds all the files. If I just want to add like one file, how do I do that?
The name of the file.
Yeah, just type in it.
Exactly. If I wanted to add all of the Python files, how would I do that?
Astra.py.
Yeah, exactly. You often hear people refer to this as star. in the coding world. But it's the same thing. And it's I think it's called the wild card in like regular expressions and stuff. And this works on the command line too, by the way. If I do ls star.py, it'll print out all the Python files. Now there's only one, so it's not very exciting, but so the star works anywhere in the command line. We've seen how to commit with git commit. Oh, what was that?
I got a quick question. If you were trying to add, like, say you have 20 files that you're trying to commit or to stage, and you do git add, but say you only want to add like 17 of those, are you able to like, do you kind of have to do it like one by one, or is there like a command where you do all except for like a specific file name?
Do it one by one.
Okay.
Yeah. The thing about Git, so here's the thing about Git, like adding and committing are pretty darn safe operations. You can't delete stuff, right? But there are other Git commands way later on that get more advanced where you can delete stuff. And especially in the beginning with Git, keeping track of stuff, if something is added, unstaged, staged, or committed can be confusing. And sort of like how with, in install fest, I was like, rm-rf / is a really dangerous command to run. And there's not sort of breaks, like safety breaks on the shell. It's sort of similar with Git. Like you shouldn't, it's better to go slow and safe and double check stuff with Git. Like if I have to do something really tricky with Git, I might spend 10 minutes making sure I understand that one line before I run it. And so, in general with coding folks, like fail fast just is the best way to learn and move forward. With Git, I would actually say it's a little bit of the opposite. Don't hesitate to hit up me or Francisco or a TA to get a second set of eyes on something. You all should not be running Git commands you're not sure about. Let me just say that again. With most of the stuff in programming, you absolutely should be experimenting and really, if I write a bad line of code, who cares? I can fix it, right? With Git, it's easy to get confused and you can paint yourself into a corner and make stuff really hard to fix. It's less likely, but you should not be running Git commands that you're not 100% about. And actually, the easiest mistake to make, I think, and let me point this out because I made this mistake earlier, is to put a repo inside a repo. So if I hop over here, so right now I'm in the Zulu demos and notes repo, and this is a Git repo, as you can see by this .git directory here. A really easy mistake to make is I make a directory and I go into it and I clone some other repo. And now I've got a repo inside a repo and I can't really tell on the command line. And this will work okay until it does not. And then it can become a major pain in the butt. Like when I type git push, which repo am I pushing to? I'm honestly not totally certain. So just try to keep an eye on how you organize things and don't put repos inside repos. There is a way to do it, but it's actually kind of not recommended in general. That was a bit of an aside, but that's probably the most common kind of gotcha I see folks fall into. Yeah, great question. Anything else that folks are curious about before we dive into branching? Okay, let's talk about branches. So, we've seen the 3 states of code in a Git repo, right? Unstaged, staged, and then committed. And we've seen how when I make a commit, it gets a unique hash. And Git keeps track of the most recent commit on a branch with this special variable called head. There's this concept of checking out branches in Git. And what this is it's as to I'm not sure if it was Tim or someone else asking like how to go back in time. But, what if I want different versions of my code? What if I want two different drafts of a file? How many of you, with Google Docs have ever, done this? Like you've got some file and then you do, my second draft or something like that. And then you make some other changes here where you might just have like 3 or 4 files with different names as you make changes. Has anyone ever done that before? So branching is sort of like that, but way better. Because what we want to do is I want to be able to have different versions of my code, and I also want to be able to combine them. And you guys won't do this now, but here's the scenario. We're all working on a team on the same project, on the same code base. And the main branch is sort of like the final working version of the code. And maybe, Max is working on a new feature, and maybe Morty is actually refactoring some existing code to make it more efficient. And maybe I'm working on a new feature as well. Well, we need to be able to do that work and not get in each other's way, right? And before we sort of bring that work officially into the code base, it would be really nice to be able to review that code, make sure it works, make sure there aren't problems, to really manage that whole process. Now take that and multiply it by like 10, because there's 10 of us, and you can imagine how tricky it might be to manage a software engineering team where everyone's working on a code base. And in fact, most software engineering teams usually don't get above 7 or 10 people. And that's why companies like have lots of different Git repos and manage stuff, because you can't actually have 20 people working on the exact same bit of code. That's too much. So they start splitting it up. So you guys aren't going to directly encounter this scenario, though we do have an exercise today to help on it. But this is the problem that branches were created to solve. Because I want to be able to work on a feature without messing with this nice, clean, working code. So I'm going to create a branch. And let me go ahead and just sort of move this stuff over here so we have a little bit of room to play with. And the way you create a branch, first of all, it matters what branch you're on. Let me say that again. It matters what branch you're on. Because like the word branch of a tree implies, we're branching off of something. And there's a newer command, but I'm so used to doing it the old school way. I do git checkout -b, and this creates a branch. We have a list. We have like a couple cheat sheets for Git. So all these commands are written down somewhere. So don't worry about memorizing this. Git checkout -b creates a new branch named my feature. And it's branched off of this existing one. I haven't made any commits. And if I type git log, I see the exact same commits from before. And what Git does is the same way that each commit points back to its previous commit. Let me get my branch direction correct. Once we do make a new commit on this branch, it just is going to point back to these commits from our main branch. So let me go ahead and make a change here. Let's make a change. Let's say for example.js, I want to add console.log goodbye moon. If I type git status, I see nothing. Let's see, nothing to commit, working tree clean, but it should have, I didn't save the file. Now if I type git status, we see that I've modified this. I'm going to go ahead and add that change. I'm going to make a commit. I'm going to say JS add goodbye moon message. And now if I type git log, I see that there. And so what I've done is, let me go ahead and just copy this and we'll bring this here and we'll call this, I don't know. And we modified example.js and we added console log, goodbye moon. So I made a commit just like we've been making commits, except I did it on a different branch. And in fact, head now points to this commit over here on the branch that I have checked out. Let's make this like a really nice big red arrow. So again, if I type git log, I see this goodbye moon message, and I see all the other commits from the branch I branched off of. In fact, I don't think there's going to be anything super interesting yet, but there's a nice VS Code extension I like. It's called Git Graph. I do recommend installing this. I'll put the name in the Zoom chat, but it's literally just Git Graph, and it's the one with 10 million installs. And what you can do is with the command palette, you can type git graph, you git graph log. And let's see here if this is showing. Right now, git graph is not looking at the right repo because I opened VS Code originally in a different directory. I'm going to be kind of lazy and fix it just by opening a new VS Code window. So forgive the extra typing here. And let me bump that up a bit. And let's open up example.js and example.py. And that's probably a bit too big. And now if I do git graph, now we see our changes. So thank you for bearing with me there. So to use git graph, you do have to make sure you've opened VS Code in the right directory because it sort of creates a VS Code workspace, I think. I'm sure there's a way to manually change it. I'm just lazy and I do it this way. And I can look at a visual representation of each branch. And here's that main branch we were working on before the break. Here's my feature branch. It kind of tells us where it branches off, and there's not very much interesting stuff. And I can look at them all, and I can, see all of them. And then my new branch actually has some changes, so that one's there. Let's go ahead and let's add one more change here as well. And let me go ahead and close out this Explorer. Let's make a new file, and we'll just call it example2.txt. And we'll just say another hello. And let me go ahead and add it and commit it. And now I have another commit on my new branch. Head points here, and we have an arrow pointing back to our previous commit. And if I look at git graph, we can see that here. And there's not that much interesting because not a ton has changed. So it doesn't really show the graph as well as I would like, because you can't really see it branching off because there's not really serious differences. So I think this diagram is the more useful because here's the nifty part. Because of the way Git works, it keeps track of the head of each branch. So I can And let me go ahead and have some open files here. And let me go ahead and do a split so we can see both files at once. So here on line 2 is the change I added on my feature branch. And this is the file I added on my feature branch. If I type git status, we see we're well organized. There's no unstaged changes, no uncommitted changes. If I type git branch, I'll get a list of branches. To switch branches, I use the checkout command. Let's go back to the main branch. Look what happened. We checked out the main branch. That code we added on the other branch doesn't exist on main. That example2 file doesn't exist. And the change I added here doesn't exist. So, Kenny, like you were asking and like folks were asking about before the break, commits track changes. And Git will actually interact with your file system and your files and modify stuff, when you tell it to do commands. And so all of our code is saved in Git. And this is great because it means like if I'm writing my code and I'm like, oh, I want to try something really cool, but I don't want to make an error and mess up this working code I have because the assessment is due in 6 hours. Well, let me make, a my experiment branch. And I could do whatever changes I want here. And if I kind of paint myself into a corner, I can go back to the main branch. And you can branch off a branch. I wouldn't recommend it. It just makes life too complicated, and it's usually not necessary right now. Later on, you will see a couple scenarios where this has value, but right now, you really should be doing like 75 to 99% of your work on main. You may not need a separate branch at all. And if you make a different branch, it should be like a backup branch or because you want to try an experiment or changing something, but you don't want to break your existing code. So I just want to check in and see what questions folks have, because this is sort of the core value of branching right here is to be able to have different versions of your code and switch between them.
I guess I'm confused between git branch and git checkout. So if you use git
Yeah,
branch, that just shows the available branches, but can you do more with git branch? As far as like creating new branches, switching as well, or you just recommend just to kind of keep the switching and then creating with git checkout?
probably, let's see. This is where the Git command line interface is kind of less than intuitive. Um, let's see. You can list branches. You can also create a new branch with git branch by using git branch -d, but it doesn't check it out. You can also rename a branch with branch M. And let me put this in the Zoom chat. And if someone can repost this in Zulu questions, actually, I'd appreciate it. This is actually a great resource. Atlassian is a really big company that makes project management software called Jira, and they have some good resources. Honestly, like renaming branches and just listing branches is when I use git branch. There is actually a git switch command now, which is newer because git checkout is so confusing. Um, and you can use it to change branches, um, to switch between branches. I got so used to using it the old way that I've just stuck with it. If folks want to use git switch, I would say more power to you. I just have it burned into my brain, and this is where the Git's user interface is a little confusing. Like there shouldn't be 5 different ways to do things, and checkout shouldn't be so overloaded. Um, I'm honestly not sure if one way is better than another. We have sort of a cheat sheet of the commands. I've been using like checkout for like a decade, so I'm so used to it. Yeah, good question. What else is on people's minds about branches, right? Because this is, I think, a key concept with Git, and this is a good time to ask questions so we can dig in.
I'm assuming if you try to, this is like a little bit further down because we haven't talked about it yet. But I'm assuming if you try to merge the branch you're on to the main branch and you haven't fully committed that branch, it'll give you like an error message to notify you, right?
Yeah, it will.
Okay.
And in fact, let's talk about merging now, and that way we can break and you all can have at least a little work time. So merging is really the last thing to talk about with branches, and then I think we can get a bit of hands-on time. So I think the natural question here, and again, thinking in the context of collaborating, is how do I combine branches? Right now that I've written my feature, people have looked at it. They're like, "Hey, Adam, good job. We like your work. How do I combine branches?" So that's what the merge command does. Um, with merging, let me make this arrow bigger. And let me get the name right. Um, yeah, source and target. That's what I wanted. So let's say I have now checked out main and I want to bring those nice features I wrote from my feature branch onto main. I need to check out main, and this becomes what's called the target branch. And this branch here becomes the source branch because I'm taking these changes here, right? And I'm merging them onto my target. So you usually merge onto main. So you'll want to go to main. And then I just type git, and let me close this out so we don't have the split. Git merge my feature. Sometimes you might get a merge commit message window pop up here. Here, there's really no issues or conflicts, and most of the time there won't be. And now if I type git log, we see that now we've basically merged these onto the main branch. So there's not sort of on paper a huge difference because there wasn't a huge difference to begin with. But now I have all my code on one branch. And in fact, an even better way to draw this would be like this. Because I haven't actually deleted anything. And if I do git graph, and we look at this graph, and we look just now at the main branch, we see all these commits. And I can still check out my feature. It's still there. It hasn't been deleted or anything like that. So that's still there, but now we've added that work to main, and now we have all of our work on one branch. And so that's a merge operation, right? And so that's how if you're working on the assessment and it's like 4 o'clock on a Sunday and you're done with everything, but you want to make like one cool change, but you don't want to accidentally break your code, you can make a branch like my experiment off of main, do your work there. And if I, screw up the code, no problem. I've still got the main branch. But if I get it working nice, I can use merge to add those changes onto main and push that code up to be reviewed. So I just want to check in and see what questions folks have about this. you won't be doing a ton of merging early on, but this is a key concept.
So after you merge onto the main branch and then you realize you made a mistake, you're kind of screwed at that point, in a way.
No, you're not screwed if you made them. It depends how big the mistake is. You can always modify your code just like you would modify any other code. The more experience you get with Git, the more structured your commits are. And so if you need to there's ways to delete or undo individual commits and stuff like that, but all that gets more advanced, right? There's a school of thought that every single commit should represent your code in a good working state. So if I need to go back in time, then that commit has a working program. But to be honest, most students, I think, just don't make enough commits and they have one giant commit that has problems in there. And it's way better to just make a lot of little commits just to get started. Oh, Chase, you're muted.
So if you in that case, like Jason said, if you merged a branch and there was an issue, could you reload the commit right before you merge the branch on the main and then go back, fix your branch, and then merge it again?
You can indeed roll back to a previous commit on a branch. Yes. Yeah, exactly. All right. Let me show you guys the assignments. And I think we'll be able to wrap by noon if we take 30 minutes. Part 2 is going to be looking at GitHub because the merging and the branches kind of make more sense once we see using GitHub. And there is some stuff to walk through here with a certain flow. But I would like us to get a little bit of hands-on time now. So here are the assignments. And I think I want you all to start with this first one. Let me show you both of them. The first one is, and it's taking a million years to load, just a series of exercises where we want you to make a new Git repo and run some of these commands. And I encourage everyone to do all of this because, again, if you know this stuff cold, it won't take you very long. And if it takes you longer than you think, it means you didn't know it quite as well as you thought. We have a cheat sheet here for you. Also, if you look at today's lesson that I've been walking through, down at the bottom of it is some really good advice, a cheat sheet, and a link to a bigger cheat sheet that has all sorts of Git stuff, not just the stuff from today. The second part of the assignment is this really great online tutorial called Welcome to Git Branching that is interactive and that you do in the browser and takes you through everything that we went through today, but it's interactive and you get to write code. I haven't used this in a minute, so I'm now honestly confused about how it wants me to do it, but it undoubtedly wants me to do something. And if I had read the instructions, I would know what to do, but I just kind of forged ahead. So it wants me to make 2 commits to complete the level. And where is my editor? It is somewhere in here. I apologize. I've probably been looking at Zoom too long. I'm sure you guys can figure this out. If you don't, let me know and I'll poke around with it as well. But somewhere in here, we can type commands and run them and run basic Git commands. And I probably just click through the window or something like that where I have too many extensions open. So you can see they've really kind of worked out a whole lot of nice visual tutorial steps. So we just want you to move through parts of this. So Yeah, and I apologize. I know this is somewhere. I think my brain has just been looking at the screen too long. I'll fiddle with it more, and if anyone runs into issues, let me know. But I think once you get going, it's pretty self-explanatory. And we would like you to work on just the first introductory sequences, just parts 1 through 3. The other ones get more advanced. So I do apologize, folks. I ran a bit long this morning. I apologize that I ate into our work time. Why don't we take a 15-minute break and come back at 11, and then we can dive into GitHub, and then hopefully we can wrap a bit early, and you guys can have some work time before lunch. And if not, I believe the afternoon is pretty open, and this is really the only assignment for today. Does that sound good to folks?
Sure.
Awesome. Yeah, and today indeed is open work time, so I think we should have a good amount of time. All right, awesome. Let me go ahead and stop the recording.